welcome back. My name is Mr. Koval, and in this video, we're going to be looking at how to determine whether you have atoms in a molecule that are coplanar or not, meaning are they in the same plane or not necessarily in the same plane. So let's get into this. So when you're dealing with whether they're in the same plane, you know they're going to be in the same plane if the atoms are if the hybridization of the atoms is sp2 hybridized, meaning that they have 3 electron groups around the atoms, and so if the atoms are connected to an atom that has sp2 hybridization, and then if the atoms themselves that are connected to the sp2 hybridized atom also have sp2 hybridization, then that's going to be all in the same plane. Also, you have to look out for the pi bonding because the pi bonding prevents rotation around the axis. So that's going to keep them either in the same plane or perpendicular. So we'll have to, determine that. But that's kind of the things that you're looking for. So let's go ahead and look at A here. So this is the atom of interest. And we want to know if there's what atoms are going to be coplanar with this atom that has the asterisk. Okay, so right away you can see that the carbon here with the asterisk has 1, 2, 3 electron groups. They're all bonding groups. And so therefore this carbon here is going to have sp2 hybridization. And so this is going to be a trigonal planar part of the molecule. So this shape here, the molecular geometry, the electron group geometry is going to be trigonal planar, meaning that all of these atoms, the 4 atoms, the central atom plus this one and this one and this one, are all going to be in the same plane. Now, can we broaden that? Are there other atoms that must be in the same plane? Okay, so then if we look at this carbon here, right, this carbon here also has 3 total electron groups around. Remember, your double bond is considered 1 electron group, not 2, right? Single, double, and triple bonds are considered 1 electron group. And so then this is also going to have sp2 hybridization, which means that this part of the molecule is also trigonal planar, right? So this is going to be trigonal planar, and because of the double bond here, one of the bonds is a pi bond. So you have one bond that's sigma, and then the other bond is going to be pi bond. That pi bond, again, as you know, is made up of 2 overlapping unhybridized p orbitals on the adjacent carbons. And so that overlap below and above the plane or the axis between the atoms is going to lock it in place. So that means that the plane of this carbon and these hydrogens, right? So this carbon and this carbon are in the same plane, right? This carbon is in the same plane as these 2. This carbon is in the same plane as this carbon and this one, right? So that means that all of these, right? So if I circle, so that hydrogen, this carbon, this carbon, this carbon, this hydrogen, and this carbon are all going to be in the same plane. Now, what about these hydrogens here? These hydrogens here are not going to be in the same plane because if you notice, they have 1, 2, 3, 4 groups around the carbon. That means it's going to be sp3 hybridized, right? Remember, the idea how to figure out hybridization is you figure out, well, how many bonding and non-bonding groups are around the atom, and the total number of groups is going to require that number of atomic orbitals. And so you take the atomic orbitals, right? So sp, we have 3 p's, and then we have 5 Ds. And for you work your way this way from low energy orbitals to higher energy orbitals. And for the number of groups that you have, that's the number of atomic orbitals you need. And so for this one, we have 1, 2, 3, 4 groups. So we need to pick 4 atomic orbitals, and we'll work our way this way. 1, 2, 3, 4. And so we're going to take these 4, and the rule is for whatever number of atomic orbitals you put together, that's the same number of molecular hybridized orbitals that you get out. So since we need 1, 2, 3, 4 of these orbitals, these are atomic orbitals, we're going to hybridize these together, and we're going to get 4 sp3 hybridized orbitals for each of the electron groups. Okay, and so because of this, we identify this carbon as sp3 hybridized, and that means that the shape around this part of the molecule is tetrahedral. So none of these hydrogens are necessarily going to be in line with the plane here. One of them could be, but not necessarily, right? So the key word here is must be, right? Why? Why are these not necessarily going to be in the same plane? Well, that's because we have a bond here, a single bond that allows for rotation. This has a pi bond, locks it into place. There's no freedom of rotation here. But for single bonds, there is a freedom of rotation. And so that keeps that, this spinning, this could spin. So none of these hydrogens are necessarily in the plane of the rest of this, not in the same plane as that one. Same goes for these 3 hydrogens. Here we have a single bond. This is sp3 hybridized. And so the ones I have circled are the only ones that must be in the same plane as the starred carbon. Okay, let's go to the next one. So for B, same idea. So you'll notice here that the starred one, this carbon. So when you draw a molecule like this, even though you don't see it, anytime you have a corner that doesn't have an atom expressed, like notice I have oxygen and hydrogen, but here I have a little corner here and a corner there, and so if you have a corner for organic molecules, typically this is the way you write them. It's understood that there's a carbon there. So we have a carbon here, a carbon here, a carbon here, a carbon here, and so on. And so here at this carbon, notice we have 1, 2, 3 groups. So again, this is going to be sp2 hybridized. So sp2 hybridized. And you can see that that's the same goes for all of these. So this carbon has 1, 2, 3, right? This is a carbon, so 1, 2 carbons and a hydrogen. So that's sp2 hybridized, right? And the same thing for this one. So that's sp2 hybridized. This one is sp2 hybridized. This one is sp2 hybridized, and this one's sp2 hybridized. So they're all sp2 hybridized, right? So that means that, again, just the same over here, this was sp2 hybridized, so it was trigonal planar, meaning they're in the same plane. So again, this carbon and this carbon and this hydrogen must be in the same plane as this carbon here with the asterisk. And then if we go to this carbon here, this carbon and this carbon and this carbon and this oxygen must also be in the same plane, and they're connected together. So if they're connected together, right, and you have this double bond there, and there's no free rotation around this bond, right? So if you have sp2 hybridized carbons bonded together, then all the atoms bonded to those carbons are in the same plane. And look, it applies to everything here in this ring structure, right? Now, that these double bonds here keep the whole thing from rotating. So this is going to be a flat molecule. So all of these carbons, so this carbon here, this carbon, this carbon, this carbon, this carbon, and this carbon are all in the same plane because they're all sp2 hybridized, which means that they have the trigonal planar molecular geometry or electron geometry in this case as well. And that means that these must also be in the same plane along with this oxygen here. Now, what about the hydrogen? Now, don't let this picture fool you because remember, there are lone pairs on the oxygen. Let's put those in. Let's make this complete. So there's a lone pair there and a lone pair here. So notice for the oxygen, you have 1, 2, 3, 4 electron groups. So this is going to be sp3 hybridized. So sp3. And since it's sp3 hybridized, that means that the electron group geometry is tetrahedral. And so that means that this hydrogen is not going to be in the same plane as the oxygen is going to be. We know the oxygen is in the same plane as the asterisk carbon, but this hydrogen is not going to be because of the shape around this oxygen. Okay. Now, last but not least, we have this molecule here. So again, this is our carbon. You'll notice that we have 1, 2, 3 bonding groups, no unpaired electrons. Let's put in the electron lone pairs on the oxygens here to be complete. So this oxygen, this carbon are all in the same plane as this carbon because you have 1, 2, 3 electron groups around the carbon with the asterisks. That's sp2 hybridized. sp2 hybridized, which means it's going to be trigonal planar again. Meaning all 4 atoms are in the same plane. So this oxygen, this carbon is all in the same plane with that carbon. So we're going to circle this one, and circle this one. Okay? So these are in the same plane as that carbon. Now, if you look at this oxygen here, you'll see that there's 1, 2, 3, 4 electron groups again. So that means that this is going to be sp2 sp3 hybridized. And again, this is going to be tetrahedral. So if this is tetrahedral, then this carbon is not going to be in the same plane because this is part of the tetrahedral structure around the oxygen as a central atom. And again, you have this rotation. You can have rotation around this single bond. So none of these hydrogens are going to be in the same plane, mainly because it's tetrahedral. And so the shape of this is not going to allow for carbon to be in the same plane with the oxygen or with the oxygen, right? So, and neither are these hydrogens going to be in the same plane because it also has a sp3 structure, sp3 shape, sp3 hybridization. And so these hydrogens and this carbon are not going to be in the same plane. However, if you look over here, you do have sp2 hybridization there, but this carbon here is in the same plane, but notice here you have a single bond, so there's rotation around this bond. So this carbon might be momentarily at some point in time in the same plane, but not necessarily. It's not the case that it must be in the same plane because of the rotation around this bond, right? So because this bond is rotating, then this carbon and hydrogen and oxygen, this whole thing is rotating. So that carbon has to be in the same plane. So none of these are going to be in the same plane. And so that, ladies and gentlemen, is how you determine what atoms in your molecule are going to be coplanar with a particular kind or particular indicated or specified atom in your molecule. So I hope this is helpful. If this video helped you in any way, if you enjoyed this video, then by all means like the video, share the video, hit that like button somewhere over there. Also, make sure you subscribe to my channel. Help me out here. When you do that, click on the notification bell so you can be notified by all the videos I put out. Click all to do that. And then make sure that you put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any problems or questions that you're struggling with, you need help with, let me know. If you have a topic you would like me to cover, let me know about that too. Put that down below. Thanks for joining me and have a great day.